Good evening all. Am I audible? Vishwanand, good evening. Preeti, good evening. Revati, good evening. Am I audible? Shravani, good evening. Yeah, good evening all. Am I audible? Okay. So let me start with yesterday's remaining topic, which is ESP8266 deep sleep with Arduino IDE using Node MCU. So shall we start the class? Good evening all. Shall we start the class? Okay, so let me start. So now we are going to see about ESP8266 deep sleep with Arduino IDE. So now, okay, just a minute. Yeah. So if you have made a project with an ESP8266 board, that is battery powered. So or if you just connected your ESP8266 Node MCU board to a power bank. So after running it for a while, you realize that battery doesn't last long, right? So especially if you are using Wi-Fi. So if you put your ESP8266 in deep sleep mode, in the sense it reduces power consumption and your batteries will last longer, right? So for that purpose we are using deep sleep mode. So having the ESP8266 in deep sleep mode means cutting with the activities that consume more power while operating, like Wi-Fi, but leave just enough activity to wake up the processor when something interesting happening in the sense. So now let's see the types of sleep. So here there is three types of sleep. One is modem sleep, light sleep and deep sleep. So coming to modem sleep, this column. So in this mode, the Wi-Fi modem is turned off while the CPU and system clock and RTC remain on. So this mode allows the microcontroller to wake up quickly and connect to the Wi-Fi network when needed. So if you are coming to light sleep, in this mode both Wi-Fi modem and the system clock are turned off, while the CPU and other components such as RTC remains on. This mode consumes less power than modem sleep but takes a bit longer to wake up. So coming to deep sleep, in this mode almost all systems which is components including the CPU and system clock are turned off except the RTC. So this mode consumes the least power and has the longest wake up time. So the table also shows the power consumption of the Wi-Fi in different state. When the Wi-Fi is turned off, it consumes no power. When it's turned on, it consumes a significant amount of power, which depends on the level of activity you are doing, which is represented by DTIM values in the table here. So the table provides an estimation of average current consumption in milliamperes for different scenarios, like assuming the microcontroller is operating at 3.3 volt power supply. So lower substrate current in deep sleep mode signifies minimal power consumption, which make this mode suitable for battery power devices where power conservation is a crucial factor. Note that the power consumption of the table refers to the ESP8266 as a standalone chip. I am talking about the standalone chip, but when we are using a development board, they have passive components that use more current. So next, I think they have provided the data science community link. So you have to go that link and submit your project in that community, I think. Here, they all have different purpose and they should be used in different applications. So, but here we will cover deep sleep mode. Everything is always off except the real-time clock, which is RTC, which is how the ESP8266 keeps track of time. So this is the most power efficient option, and the ESP chip only draws approximately 20 microampere. However, if you use a full feature development board with a built-in programmer in the sense, or LEDs and so on, you won't be able to achieve such a low power state. So coming to wake up sources, there are different ways to wake it up. So after putting the ESP8266 in deep sleep mode, how can we wake it up? There are two ways. One is timer wake up. The ESP8266 wakes itself up after a predefined period of time. Another way is external wake up. The ESP8266 wakes up when you press the reset button. So the ESP8266 restart. So let's see one by one. So first one is ESP8266 wake with timer wake up. So to use timer wake up with ESP8266, we need to connect the reset pin to the GPIO 16, which is labeled as D0 in a Node MCU board. But we have to connect the reset pin to the particular GPIO pin, which is 16, only after uploading the code. So when you are uploading the code, after only you have to connect the reset pin to the GPIO 16th pin. So the reset pin of the ESP8266 is always high while the ESP8266 is running. However, when the reset pin receives a low signal, it restarts the microcontroller. So if we set a deep sleep timer with the ESP8266, once the timer ends, GPIO 16 sends a low signal. That means that GPIO 16, when connected to the reset pin, can wake up the ESP8266 after a set period of time, which you have mentioned in your code. So now let's move to the coding part. Open your Arduino IDE. Here first, let me erase it. I am going to write it from fresh. So first I am going to mention void setup function. Is the screen clear? Are you able to see this? So inside void setup, I am going to initialize the baud rate of 9600 bits per second for serial communication. So serial dot begin. Inside I am going to give 9600 as baud rate. So now I am going to use another function called serial dot set timeout. Serial dot set time out. So as an argument I am going to pass 2000 millisecond. So this line sets the timeout for the serial communication to 2000 millisecond, which is 2 seconds. This means that if no data is received over the serial port for 2 seconds, in the sense, the serial communication will be stopped. For that purpose, we are using this serial dot set timeout function. So now let's create a while loop. So while inside I am going to give not equal to serial and I am going to leave it blank. So this line waits in a loop until a serial connection is established. So this is useful if you want to wait until you see the output of the board over the serial monitor before proceeding. For that purpose we are creating a while loop. So now let's print the message. Serial dot println. Inside let's print a message like I am awake but I am going into deep sleep mode for 30 seconds. So this is what I am going to print. Then now let's put the board into deep sleep mode for 30 seconds. For that I am going to use esp dot deep sleep. Inside I am going to give 30E6. So the parameter given to the function is the number of microseconds the board should sleep for. Here we are going to make it for 30 seconds. So 30E6 is scientific notation for 30 lakhs microsecond, which is equal to 30 seconds. So then coming to void loop function. Inside I don't want to give anything because in this case we don't need to do anything in the while when the board is sleeping, right? So this is our code. Let me verify it first. Before that, make sure that you have connected the correct board and port 4. So now let's verify it first. Let us wait for a few seconds to verify it. Have you tried the yesterday's session? ADC, pulse width modulation. Have you go through that? Are you clear with this topic, deep sleep? Does anyone have any doubt regarding this? Thank you for your response. It's good to hear. Taking so much of time. Shravani, okay. With this again. Do you want me to repeat the code or the topic? Okay, now our code is error free. So before making the connection, we have to upload the code into the microcontroller. So let me upload it. Let's wait for a few seconds. So deep sleep is nothing but if you made a project using batteries with Wi-Fi, in the sense the battery doesn't last long. So if you want to use your battery for last long, in the sense, for that purpose we are using deep sleep to save power. This is the main concept of deep sleep, to save power. For saving power concept, in the sense we are using deep sleep in our code. T6 is nothing but we are going to make our ESP8266 into deep sleep mode for 30 seconds, right? So the 30 seconds is 30E6 in scientific notation, which means 30 lakhs. We have to pass the seconds inside the bracket as an argument, right? We have to give 30 seconds, which is 3000 millisecond. Sorry. Yeah, 30 lakhs millisecond. For that purpose I give 30E6 is a scientific notation as an argument. So yeah, let me open a serial monitor now. For that we have to connect. Okay, now we have to give D0 pin with reset button. That's it. So here it is. So every 30 seconds it will be awake and print a message like I am awake but I am going to into deep sleep mode for 30 seconds. Make sure that you have to select the same baud rate as you have given inside as an argument. So 9600. It will print the message for every 30 seconds. This is our output. Yeah. So now let's move to the next topic. Okay. So yesterday we see ADC and pulse width modulation, right? So ADC, pulse width modulation and deep sleep are important features of the ESP8266 microcontroller that allow it to interface with analog signals. It can use to control power delivered to devices and conserve power when not in use. So understanding these features is essential for designing efficient and effective ESP8266 based projects. So now we are going to see about the sensor interface. So before getting into the interface, first we have to know what is analog sensor and what are digital sensors, right? So for that, analog sensor. So what is analog sensor and why it is used? An analog sensor measures a continuous physical quantity such as temperature or pressure and produces an output signal that is proportional to the input. So the output signal is typically a voltage or current that varies continuously with the input. For example of analog sensor like thermocouples, pressure sensor, etc. And coming to digital sensor, a digital sensor produces an output signal that is in the form of discrete value or digits, usually in binary code. So digital sensor typically use an analog to digital converter to convert the analog input signal into a digital output signal. For example of digital sensor like optical encoder, proximity sensors and temperature sensor, etc. So the choice between analog and digital sensor depends on the application requirement. Analog sensor are often preferred for application where precise measurement of a continuous physical quantity is required, such as in temperature or pressure sensing. Digital sensors are often preferred for application where discrete or binary data is required, such as in position sensing or motion detection. So simply, if you prefer temperature or pressure sensing, in the sense, you can go for analog. So if you want to measure position or if you want to detect any motion, in the sense, you can go for digital. So now let's move to the topic. So today we are going to interface IR and LDR sensor. So our today topic is smart street light using IR and LDR sensor with ESP8266. So most of the places have automatic street light which can sense the daytime and night time and automatically turns on and off according the day and night, right? So here we are extending this by adding one more constraint to turn on the light. That is, street light will only glow if there is darkness and someone or the vehicle is passing through the street. So the main objective of this is to reduce the power consumption. You can take it as a mini project too. So if you are a beginner, in the sense, you can do this as a mini project. So by glowing the street light only when it is needed, here we are demonstrating the prototype of the smart street light. With here we are going to use only one IR sensor and one LDR sensor and one LED. One LED is for IR and another LED is for LDR. So now let's talk about the sensor. First, IR sensor. So, IR sensor is an electronic device which is used to detect objects by sensing infrared radiation reflected from the object like this. It mainly consists of a transmitter IR LED and a receiver photodiode. These two. So, it detects infrared radiation which have wavelength from like 700 nanometer to 1 millimeter. So when a specific positive voltage is applied across the transmitter LED, it transmits the IR rays. This. So if these rays fall on some object, then the object reflects back the IR rays which are received by the receiver photodiode. So the receiver diode generates a voltage across its terminal which depends on the intensity of light reflected by the object. So generally IR receiver LED is darker which is in black, whereas transmitter is transparent in color. So this is the receiver, this is the transmitter like emitter. So this is about IR sensor. Now let's move to LDR sensor. Okay. So LDR sensor stands for light dependent resistor and also known as photoresistor. So LDR is sensitive to light and its resistance changes according to the intensity of light falling on it. It is made up of high resistance semiconductor, this one, and its resistance increases in darkness and decreases in light. When light incident on the LDR exceeds some threshold, it absorbs the photons and allows electrons to jump into the conduction band. So LDR generates a variable resistance which depends on the intensity of light falling on it. This is the concept. It is mainly used in electric circuit like street light, alarm clock, automatic brightness and contrast control, etc. So this is about the IR sensor and LDR sensor. Are you guys clear with this? Let us move to the coding part. Shall we move to the coding part? Are you guys understood this? Is it clear? If you understood the concept in the sense, just type yes or drop the thumbs up emoji in the chat box, please. If you have any doubt in the sense, you can ask me. If you have no doubt in the sense, let's move to the programming part. Yes. Okay, thank you for your response. Sammy LDR, okay. So LDR is nothing but its resistance change according to the intensity of light falling on it. So when it's darkness, which means night time, its resistance will increase. So when it's daytime, its resistance will decrease. So you can both this as an analog and digital. So if you are taking digital in the sense, it will only give an output like 0 and 1. If you take analog in the sense, it 10-bit resolution, it will be 0 to 1023. So based on the light which is falling on it, its resistance will change according to the number between 0 to 1023. So after writing the code, let us interface the components, then you will get a clear idea about that. Is it clear? Riddle quiz, you can better change the USB cable. Just try some other USB cable. Try it then. Sometimes your USB cable doesn't support, so that's why you can you will get a error like that. So just try to use some other USB cable, then try it once. And make sure that you connected it properly to the PC and your microcontroller. So make that sure. USB cable is not pen drive. You are charging your phone using USB cable, right? That is the USB cable. B type, C type. So here you have to use B type USB. Okay, now let's move to the coding part. So first what I am going to do is I am going to initialize all the pin number. So here we are going to use LDR sensor, IR sensor and LDR's LED and IR's LED. So we have to initialize 4 pins here. So I am going to give data type is integer. First let us initialize LDR. So let's take any pin number. Let us give D6. So then integer LDR's LED. So let's give D3. Then IR number, which is D like 5 and IR's LED, which is D2. So this is our pin initialization. Now let's move to the void setup function. Yes, you can use ESP32 also. That is slightly some difference between ESP32 and ESP8266. You can use ESP32 or you can use ESP8266. Both are fine. Okay. So inside void setup, I am going to give serial dot begin 9600, which is for communication purpose. Now I am going to mention pin and its mode. So using pin mode function, I am going to first mention LDR. It's a sensor, right? So we are going to read the sensor and we are going to store it in a variable. So we have to give us an input. We are going to read something from something in the sense we have to give it is an input. If you are going to write in the sense we have to give it is an output. So this is input and pin mode of LDR LED, which is output. We don't need to read anything from the LED, so it is output. So then again pin mode IR, we are going to read it, so input. So pin mode IR LED, which is output. So yeah, that's it. So now void loop function. Serial begin is for communication purpose. We are going to do a communication, right? We are going to read the sensor, we are going to store it in a variable, and we are going to use for that purpose we are using serial begin. Inside we have to pass the argument which is baud rate. So inside void loop, I am going to read data from sensor and going to store it in a variable. So int LDR value. In ESP32 and ESP8266 both will operate at 3.3 volt. That is the voltage. LDR value, here I am going to read it. So analog read, inside I am going to read LDR sensor first, and again I am going to make another variable called IR value. So again I am going to read IR sensor, I am going to store it in a variable called IR value. Now we have to make conditions. If condition, first condition is for night time. So for that, here let's make a comment. Night. So if condition, inside I am going to give if. Here I am using both LDR sensor and IR sensor in digital mode, not in analog mode. So digital in the sense we either get 0 or 1. So if LDR value is double equal to 1, which means high, the meaning of if LDR value double equal to 1 in the sense if it is night time, then my LED has to become high. So digital write, inside I am going to give LDR LED has to become high. So now I am going to make another condition for vehicle detection. So I am going to give another if condition inside this if condition. So if it's night time, my LED has to become high, and also it has to check IR value to become 0. So here I am going to give digital write of IR LED also has to become high if it detects any vehicle in the sense. If you have any doubt in the sense, you can contact office number, then you can reach me. So call to the office number or put an email to the official mail ID. So here I am going to print a message like serial println like it's night time and vehicle detected. I am going to print like this, and I am going to make a delay for 2 seconds, which is 2000. Okay. So if IR value double equal to 0 here, which means vehicle is detected, then the LED has to be high, and then it has to print the message like it's night time and vehicle detected, and I am ending with delay here. So now another if condition is for no vehicle detection during night time. We are going to make 4 conditions, 2 for night time and 2 for daytime, and first night time is for vehicle detected and another one is for no vehicle detected. For that purpose we are going to make 4 if condition. So same, if LDR value has become high, inside I am going to make digital write of LDR LED has to become high because it's night time, right? So again if condition IR value, which is 1, no vehicle detected. 0 means vehicle detected, 1 means no vehicle detected. So digital write, no vehicle detected means there is no need for LED, so it has to become low and has to print message like it's night time and no vehicle detected. So we have to give a delay of 2000, which is 2 seconds. So yeah, so now it's for daytime. If LDR value is 0, which is daytime, inside I am going to give digital write. Daytime there is no need for LED, so LDR LED has to become low here. So now it's for vehicle detection, IR value double equal to 0. If vehicle is detected in the sense, digital write inside my IR LED has to become high. Serial dot println, I am going to print its daytime and vehicle detected. Now let's give delay of 2000. So another if condition, it's for daytime and no vehicle detected. Then if inside we have to give LDR, right? So LDR value becomes 0 inside digital write LDR LED has to become low. Then a time to check IR value. If no vehicle detected, so inside we have to give digital write IR LED become low if no vehicle detected in the sense. So serial println, inside I am going to give it's daytime and no vehicle detected. So let's end it up with delay of 2 seconds. That's it. So let me check it once. So very first we have declared the initialize the pins, which is LDR, LDR LED, IR and IR LED. So inside void setup we started with serial communication, which is 9600 baud rate, and we have mentioned the pin and its mode. LDR and IR is sensor for so input, and LDR LED, IR LED is output. And inside void loop we have read LDR and store it in a variable called LDR value, and then we read IR and store it in a variable called IR value. Then first we start up with a condition for night time. 1 minute. So yeah, so we check it's night time or daytime. So if it get 1 in the sense it is night time, the LED has to become high. So LDR value and LDR LED. So then we are going to check if vehicle detected or not. So 0 in the sense vehicle is detected. So if vehicle detected in the sense the corresponding IR LED has to become high. So then we are going to print it's night time and vehicle detected. And the next condition is for no vehicle detected. So LDR value 1 inside night time our LED has to become high. So LDR LED is high, and now it's time for vehicle detection. So if no vehicle detected in the sense it has to become 1 and our LED has to become low, and it has to print like it's night time and no vehicle detected. Okay, I gave LDR here, right? So no, sorry, here it has to become IR LED. So no vehicle detected in the sense the IR values corresponding LED has to become low, which is IR. Sorry for this. And third condition, it's for daytime. So LDR value is 0 in the sense our during daytime there is no need for LED. So here is for vehicle checking. So 0 means vehicle is detected. So vehicle is detected in the sense the LED has to become high and it has to print a message like it's daytime and vehicle detected. So last condition is for daytime. LED has to become low. If no vehicle detected in the sense the corresponding IR LED has to become low and it has to print a message like it's daytime and no vehicle detected and delay. That's it. So yeah, let us verify it first. Okay. Our code is error free. So now let's move to the hardware part and make the connection. Is it visible? Okay. Let's start with the connection. So here we are going to use, this is LDR sensor and this is IR sensor. First let me connect the LED. So one LED is for IR and another LED is for LDR. Okay. So here, let's go to the pin number. So here LDR LED is D3, right? So here I am going to give. So this is our LDR LED. And the green light is our IR's LED. So LDR's LED is D3 connected to the D3 pin and the negative side of the LED has to connected with ground pin. So here. So next IR LED positive side has to be connected with D5, right? So D5 is here. And the ground has to be connected with the negative side of the LED. So now okay, here is our LDR. So first VCC we have to connect it with 3 volt and the ground pin has to be connected with the ground here. And the digital output pin has to be connected with our LDR pin is D6, right? So here it is. Then IR sensor, similarly 3 volt and then ground, and the output pin has to be connected with D2. Here it is. So if I move my hand in front of the sensor in the sense, so here are you able to see this? The LDR is blink. I move my hand in the sense, the LDR will off. So if vehicle detected in the sense, our LDR will be high. No vehicle detected in the sense, our LDR will be low. So let me here. let me upload it code first. Make sure that you are connected the particular port and component. Okay, so I'm uploading the code now. Let us wait for a few seconds. Here you can see that if I light falling on it in the sense, so light falling on it in the sense, here you will see the two LEDs blink, right? So it means it's daytime. So now it's night time. Daytime, night time. So yeah, our code is uploaded. Now let us see the output. So open your serial monitor here. So it's daytime. If the connection was loose in the sense, the output doesn't come properly, so make sure that so it's daytime. I don't know why the output doesn't come properly print on the serial monitor. I think there is some issues with connection and my sensor, I think. So sorry for this. So I will show the output in tomorrow's class. I'm sorry for this, my sensor doesn't work properly. I'll show the output in the next class. Is it okay? Am I audible? There's something problem with my sensor. I will show the output in the tomorrow's class. Okay. So just try it with yourself. If you have any doubt in the sense, you can ask me in tomorrow's class. And also I will show the output in tomorrow's class also. Just make your own code. And if you have hardware in the sense, give it a try. So let's wind up it here. Thank you all.